Mr. Hayes, we're here, and I want to go over the group review we did to prepare for the Chapter 3 test. This video is going to go over the first 3 problems because they deal with rational expressions. We're going to look at the operation of subtraction, which will help us with addition, and then we're going to look at dividing, which could help us with multiplication. And the last problem we're going to look at for this video deals with complex expressions. So we're just going to dive in and look at what the differences are between them to help us prepare. So the first problem says subtract the rational expressions, and I'm going to highlight right now the word subtract because that is the key to this one. When I say the key, I mean it's where the mistake occurs on these problems with a lot of students. But primarily, the main thing to realize is whenever you are adding or subtracting rational expressions, you need to find a common denominator. That's a key, whether you're dealing with rational expressions involving variables or just numbers like 1/2 and 3/5. They need a common denominator to be added or subtracted. So I'm going to factor the x squared plus 3x minus 54, and that's going to give me x plus 9, x minus 6. Now that's helpful because a common denominator has to have the same denominator, and I can see right now that the first fraction has x plus 3, and it's going to be over my x plus 9 and my x minus 6. However, the second fraction only has the x plus 9. Well, if I want them the same, they have to look the same. And so I'm going to use a clever form of 1 to create a common denominator. So I'm going to multiply the bottom by x minus 6 and the top by x minus 6. Because really, that's the number 1. That creates the same denominator, x plus 9, x minus 6. Now before I move any forward, I'm going to realize there's always a stipulation whenever you're dealing with rational expressions. There's always something to be cautious about, and that is that you cannot divide by 0. So I'm going to find what are my excluded values first, and those are where you create a denominator of 0. So if I set x plus 9 equal to 0, I'm going to get negative 9. So x cannot equal negative 9. And for this one, x cannot equal 6. So that's going to come into play when I write my final answer, but at least I've found it now. Well, now they have the same denominator, and I need to keep that in mind. When you have a common denominator, you're already halfway down with the fraction. You know what the denominator is going to be. My job is to simplify the top. And I'm going to show you where another mistake occurs. Is when we're doing x plus 3, they now have the same denominator, so I'm going to do minus 3x times x minus 6. I'm going to write it all over the denominator x plus 9, x minus 6. And I'm not going to change the denominator. I'm not going to cross anything out. I'm going to keep it, and it's going to stay there till the end, or very close to the end if I have to simplify. But I want to point out, here's what I notice on some of the quizzes. Is at this point, people go, oh, there's an x minus 6 in the top and the bottom, so I can cancel them out. And that is not the case here. And the reason why is because there is a subtraction sign. The only way you can cancel out common factors in the numerator and denominator is if it's all multiplication. And we have a minus sign, so that is not possible. So that's warning number 1 for you. At this point, it's kind of like the idea that you are going to keep that denominator. I mean, you found it. It's going to stay there for us. And what I'm going to do is I'm going to distribute the top. So I have x plus 3 minus 3x squared, in this case plus 18x. Again, I'm just going to simplify the numerator. The denominator, that x plus 9, x minus 6, that's just going to stay. Not going to do anything to it. But the top, I'm going to write in standard form. So that's negative 3x squared. That's a 19x, and that's a positive 3. But I have these excluded values. So I'm going to write it in my final answer. So when x does not equal negative 9 or 6, and there we're done. So things to be cautious about here are the people who are trying to cancel there. And by doing that, you're ruining the common denominator that you created. I mean, right here, look at this. We found, well, I'll circle it where it belongs, right here. We found x plus 9, x minus 6 right away as a common denominator. And look at our answer. X plus 9, x minus 6 is the common denominator. It didn't change. The only way that common denominator could change is if I had the ability to factor the numerator. After it's one single fraction, not separated, but no, I distributed, I combine like terms when it's right here in standard form. If I can factor, and then see if you can cross out. Do not do it in the middle of the steps. Wait until after you distribute and combine like terms. All right, so we have problem number 1 done. Problem number 2 is something different. It's dividing. And some of the things I've seen is that students are going, well, I need a common denominator. And you don't when multiplying. Think of it like numbers. If I have 1/2 times 1/3, it's 1/6. You don't need a common denominator. So that's the difference between addition, subtraction with rational expressions, and multiplication and division. So here we go. We're going to take a look. I'm just going to straight factor everything. I'm going to go numerator, denominator, and I'm going to factor it. So I'm going to write x plus 2, and I'm going to put it in a parentheses just to make myself feel good. All right, and right here now, 3x squared minus 9x. Here's one that keeps being missed. GCFs, greatest common factors. When you see that they have multiples of each other in some way and that they have a variable in common, you have to take out a greatest common factor. And so I could see 3 and 9 has a multiple of 3, and x squared and x has a multiple of x. So I'm going to factor out a 3x, and that's going to give me an x minus 3. So I factored the numerator, I factored the denominator. Well, now I'm going to take a look. Wait a minute. That's division. So I'm going to change it to multiplication, and I'm going to flip when I factor over here. So the 12x squared minus 36x goes to the top. It goes in the numerator. So in that case, what do you notice? Well, it's GCF again. So notice we might be trying to focus on something. That's a common missed thing. And it happened on the 3-1 check-in quiz as well. So 12x. And it gives me a remaining factor of x minus 3. And I'll go to the 2x to the 4th plus 4x cubed. Again, oh my goodness, is a GCF again. Can you believe that? So maybe we're trying to point out where some errors occurred on the check-in quiz. So that would be 2x cubed. And that'd be an x plus 2. So now that it's factored, when we take a look at it, it's at this point you have the ability, and it's fun, I enjoy it, of crossing out common factors. And the reason why we can do this here is because it's all multiplication division. And I can hear some of you saying, well, there's a subtraction sign there, there's a plus sign there. However, that plus sign, minus sign is contained inside of a factor that is being multiplied. It's being multiplied. It's being multiplied. It's all multiplication division. So I can cross out common factors. I can cancel them out because they create giant ones. Anything divided by itself is 1. So I'm going to go to red. I have an x plus 2 here. I have an x plus 2 here. They're gone because anything divided by itself is 1. I have an x minus 3. I have an x minus 3. Gone. Now, I could do more here, but I want to point out what happens on the check-in quiz for this. Was when we went and did this, people would go, oh, I have a 12x on the top, which is right, and I have a 6x to the 4th, which is right. And then what happened is students left it. I mean, 12 over 6. We can simplify that to equal 2. So we're going to simplify the coefficients like a fraction, but then x over x to the 4th means you have an x cubed in the bottom, and that's the final answer. So be cautious on this. When do I create a common denominator? When I'm adding or subtracting. When do I factor and cross out? Well, when I'm multiplying or dividing. And I have to be careful with my coefficients in simplifying them. So there's number 2. Let's go to number 3, the last one in this video. This is a complex fraction because, man, it looks complicated and it can be intimidating. However, the best part about math, the best part about algebra in general is you can take something that is intimidating as this and make it into something simple. You have to manipulate it. You need to be clever. And so I'm going to take my 5x over x plus 2 minus 3. I'm just rewriting right now, and I'm going to write a little bit bigger so I can have some room. And I have a 4 plus 7 over x plus 2. All right, so here we go. What do? Well, some people want to go, I'm going to work in that numerator by itself, that 5x over x plus 2 minus 3, and I'll work with that 4 plus 7 over x plus 2 by itself as well, and I would do that. But I need to keep in mind that's just going to involve a lot of work. What makes this complicated? What makes this complicated is that you have a fraction in the numerator, you have a fraction in the denominator, so your job is get rid of the complicated part. That's your job. Get rid of it. So I look, what makes it complicated in the top? Well, it's an x plus 2. There's a fraction with the denominator of x plus 2. Well, if I were just to think about the top, the common denominator in the top is x plus 2. Now let's put that on hold. Put it on the back burner and let's figure out the bottom. What's the common denominator in the bottom? That also is x plus 2. And by the way, that's awesome that they match, because if they match like this, it gave me the answer. It tells me what to do. If they didn't match, I'd have to find a common denominator between these two and then do what to do next. But the fact that they match is going to make my life simple. It's that x plus 2 denominator in both the top and the bottom of the complex fraction that is making it difficult. So, get rid of it. I'm going to multiply the top fraction by x plus 2. And I'm going to put it over 1 so we can see what gets multiplied bottom. But I'm going to also, because I can't just change the top of the fraction, I have to also change the bottom by the same amount. That's multiplied by a clever form of 1. In class, we call this a super giant 1, a super giant, enormous, mega 1, whatever you want to say. But you're being clever. You're tricking the problem. You're really multiplying by 1. So here we go. When I distribute, and I'll do it to the top first, when this goes to here, you have an x plus 2 in the top that's being multiplied to the 5x, and I have an x plus 2 in the bottom. And if you want to see it off to the side, I can show you, here's what it's going to look like. Well, that's all multiplication, so that means I can cross out common factors in the top and the bottom. So those would go away, and I would only be left with a 5x. So that difficult part in the top, that x plus 2 in the denominator, gone. Now I distribute here. So that's going to be minus 3 times x plus 2. Now, I could see right here, I know I have to distribute and combine like terms, so I'm just going to do that off to the side so I can put this numerator completely to rest, and I'm going to say this would be a 2x minus 6 after I distribute and I combine like terms. And I'm going to do the same thing in the denominator. I'm going to distribute, and that's going to give me a 4 times x plus 2. And then I'm going to distribute here, and the same thing is going to happen. I'm going to have a 7 times x plus 2 with an x plus 2 in the bottom. And those are going to cancel because that's all multiplication. So I'm going to be left with a plus 7. Again, I'm going to end up distributing, and I'm going to be ending up combining like terms, so that's going to be 4x plus 15 after I distribute and combine like terms, and there's my answer. I'm done. The part that made it complicated is the part you get rid of. That's the best part about math, is take something that looks difficult and make it into something a lot easier to deal with using the skills you already know. And all we did was multiply by the number 1. That's all we did. We were smart about how we multiplied by the number 1. We created a clever form of 1 that would get rid of the 2 things that were causing difficulties for us. Now, I want to talk about what I did here before I end the video for this. Do you notice when I did the blue, when I did the distributing up here, when I did that, right away I went right into this part and I simplified it. And you notice I did the same thing with the green. Right away when I went here, I went to this. I didn't try and work with the blue and the green together here. Now think about this, because I addressed this previously in the video. At this point, there have been students, like I said, who go and say, oh, I have an x plus 2 in the top and I have an x plus 2 in the bottom, so I'm going to cancel them out. You can't do that because it's not all multiplication. I mean, look up here. This is all multiplication going on, so that's why I get to cancel. This is all multiplication going on, so that's why I get to cancel. This has a minus and a plus sign, so you are not allowed to cancel. So what I did is, as soon as I got to this position in the work, I knew what I had to do next was distribute and combine like terms. So I didn't let a structure, cause me any problems in the future. I just went ahead and simplified it because it was an easy thing to do. And then the same thing here. So that's some advice for you when you're dealing with these complex fractions, is you know what you need to do to this top, so go ahead and do it. That way it's completely done. And then you're not going to make a mistake. So there's the first three problems, and we'll continue on with some more videos on this.